All right, so again, as we are working through these, again, to highlight the first two, I need you to write two equivalent fractions for the given fraction. And again, when we check our answers to these two, and we also check our answers to the homework from last night, there are an infinite number of correct answers. So you can't say, well, those aren't the two that I had, because it just simply depends on what you choose to multiply or divide by. Now, here's the one thing I will tell you. You can't choose to multiply your top and bottom by 1 because you're not writing in a different fraction. Okay? Yes, it's equivalent, but it's not a different fraction. We're looking for a different fraction that is equivalent to the one that is given up here. Okay? And then again in number 3 and 4, I don't care if you're using factor trees to find your greatest common factor, if you're listing factors, and I'll be honest, some of you are just starting to get to the point where you can mentally compute finding greatest common factors. Whatever works for you is what I want you to be able to use. I'm not going to tell you that you have to stick a strategy and just continue to use that all the way through. So, for problem number 1, let's see. Today is going to go to, let's get this loaded here. Maybe. Random student selector. Bryce, you've got number 1. Number 2 is going to go to Kane. Number 3 goes to Serena. And number 4 goes to Evan. That's fine. We'll get you through it. That's fine. We'll get you through it. What's up?
So for number 4 and 5, so like
There's no number 4 and 5. There's a 3 and a 4.
I mean 3 and a 4.
Yep.
For 3 and 4. When you times the 15.
Well, but you got to break 15 down, and you got to break 25 down. If you're going to do it like this, you got to do your prime factorization. All right, perfect start. Okay, now let's do that with 25 over here. What's 25 going to break into? 5 and 5. Okay, so now we're going to write out 15x squared y squared. What can we write that out as? 5 times 3. Nope, you write it out as a multiplication problem. So you're going to write it as 5 times 3 with 2 x's, right? And 2 y's. Okay, and then let's write below this what we have here. So just write, 5 times with 3 x's and 1 y. So now what do these have in common? There you go. Okay, and what's x times x? X to the second power, so it's going to be 5x squared y. There you go. No, I don't need to see the computational. Your work is good with what you've got up top there. All right, so let's take a look. So problem number 1. Remember our rule. This was the big idea that we talked about yesterday. In order to write an equivalent fraction, you either multiply or divide the numerator and denominator by the same number. Okay, because again, when we look at our work here, what is the fraction 2 over 2 actually equal to? It's actually just equal to 1. So all we're doing in this problem is we're multiplying it by 1, but we're multiplying by 1 that looks a little bit different. So in this case, we're taking 16 over 18, multiply the numerator and denominator, in this case, both by 2. So you multiply the top by 2 to get 32, you multiply the bottom by 2 to get 36. This fraction is equivalent to this fraction here. Okay? And in this one here, you can also, because they're both even, you can divide them both by 2. So 16 divided by 2 becomes 8, and 18 divided by 2 becomes 9. This is also an equivalent fraction here. Now, yesterday we did a lot of, as I walked around, I saw students doing a lot of the multiplication ones, which is great because, again, it still gets us to the idea of what is an equivalent fraction. Today, though, we're going to be dividing all of the time because our goal today is not just to write an equivalent fraction, but to write the fraction in what we call simplest form. Okay? So that's why I asked, if ever possible, go ahead and do an operation of each of them. Do a multiplication and a division just so we can start to think about it in that way. Okay? In problem number 2, we have 24 over 37. Okay? Again, you can choose any number you want. So who had number 2 for us here? Is this Kane? Kane chose 7 and 7. Because 7 over 7 is the same as 1 again. So if I multiply 24 by 7, we're going to get 192. And 32 times 7 is going to give us 256. This fraction is equivalent to the given fraction. And then they are both even, so you could divide them both by 2. So you could take 24 divided by 2 to get 12. You could take 32 divided by 12 to get 16. 12 over 16 is also an equivalent fraction. This is actually one, ladies and gentlemen, where you could divide by several things. You could divide the top and the bottom both by 2 like Kane did. You could divide the top and the bottom both by 4. You could divide the top and the bottom both by 8. Okay, you could have found several different equivalent fractions using just division and not even multiplication. All right, and then number 3, our greatest common factor. Again, I'm not really going to worry too much about how we find it anymore because I'll be honest, this is what we practiced last Thursday and Friday pretty hardcore. Okay, doing greatest common factor and everything else through that, whether it's prime factorization or anything else. So, just look at it, 36 and 24. When you're done, whichever method you use, your greatest common factor should be 12. Again, I'm just going to throw this one out there to give you guys something to think about. We showed this a little bit yesterday. 36 and 24. And again, the larger numbers you find, the quicker this becomes. 36 and 24, I know, are both divisible by 4. What's 36 divided by 4? You guys all have calculators if you don't know. 36 divided by 4 is 9. And 24 divided by 4 is 6. What is a number that goes into both 9 and 6? 3. 9 divided by 3 is 3, and 6 divided by 3 is 2. Are these two numbers, do they have any other common factors? No, what do we call that? They're relatively prime. Now remember, the product of these two numbers is your greatest common factor. When you multiply that 3 and 4 together, you get 12. If that's a strategy that you like because it's shorter than the factor tree, by all means you can use it. Okay? Then number 4, looking for prime factorization of our numbers and then also our variables. So Evan broke down 15, she broke down 25. Now remember, your variables, exponents, are going to tell you how many x's and y's are in each of these. So in the first one we have 2 x's and 2 y's. And the second one, we have 3 x's and 1 y. So when we look at this, if this has 2 x's and this has 3 x's, how many do they have in common? They have 2. That's why an x squared is part of that answer. If this has 2 y's and this has 1 y, how many do they have in common? 1, which is why y to the first power is part of our greatest common factor as well. Remember, you're always looking for the fewest number of x's and y's. That's the part that carries over to the final answer. So our greatest common factor in problem number 4 should be 5x squared y. Now, why are we doing any of this? Because ultimately we're going to take finding greatest common factors, writing equivalent fractions, and we're going to start pulling those together. Okay? We're going to reduce fractions today, both with numbers and variables. We're going to expect you to be able to do that with greatest common factors whenever possible. So let's take a look at the homework assignment from last night. It's coming up here on the board. And again, this is one of those that it's going to be a little weird because not The two answers that are listed up here are not the only two correct answers. They are two correct answers, but they're not the only ones that you could have. I'm not going to go through and say, could I have this, could I have this, could I have this, could I have this? Because we literally could be here all day. So this is why your work is important, making sure that you've got an understanding of what is required so you know that you found the correct ideas. These are examples of two equivalent fractions for each of the given ones. And again, it's maybe a little hard to check, but if we look at your work and you've done your computation correct, then you know that you should have two equivalent fractions there. Bryce, question.
Let's feel like a check the bar exactly right since it's very likely.
If you want to check, that's a great question. Everybody grab your calculator, please.
Since it's very likely our answers are not going to be the same.
This is how you're able to check your answers. So, let's take an example for problem number 3. Take the given fraction. The given fraction in problem number 3 was 12 over 16. Okay? This is nothing other than a division symbol. It's just a fraction bar. So somebody asked the other day, where is a fraction bar on this calculator? We don't have them in high school. Like, I know some of you guys were used to like that mixed number, improper fraction, but in high school we don't use that. Fraction bars are division symbols. So use a division symbol. What's 12 divided by 16? What's your calculator give you? 0.75. So, if you think you have an equivalent fraction, type in your equivalent fraction. An example would be 24 over 36. If you type in 24 over 36, you should get 0.75. You should get the same decimal answer. Because mathematically, they are equivalent fractions. They have the same values. Your calculator is going to give you the same value, even though you're typing in different numbers along the way. All right. So, again, it's a little vague, but any specific questions that we've got on the homework, 2 through 6 or 12 through 19, please make sure you read the directions. Tomorrow, when you take your check, if you write one equivalent fraction and that's not going to be enough because it specifically says 2. Okay? When I wrote your assessments, I pretty much copy the directions out of the book. That way I'm not asking you to do something brand new. So if you're doing your homework and you're reading the directions the way they're meant to be read, you shouldn't look at it and be like, I don't know what they're asking me to do here, because they're literally copied out of the textbook. Okay? The problems themselves are different, but the directions are not any different than what you see every night when you do your homework. All right, any others? Okay, now, just a couple quick kind of housekeeping things, and then we're going to go ahead and move on. Number 1, does anyone else, I got another one today as I was walking around grading homework, anyone else got the remediation worksheet or ticket? I do not have a ton of these. Remember, I handed them back last Wednesday, I asked for them last Friday, today is Tuesday, and I still probably only have half the classes. Okay? I need these back, ladies and gentlemen. So if you haven't seen a guardian at home yet, you need to make some time, and literally it's a 3-minute conversation for most of us. All right, now a couple other things to kind of housekeeping about that. I'm proud to say that after the very first assessment, there was no incompletes or level 1s. Now, what that means in my book is I'm not requiring anyone for RTI. Okay? If I still have an incomplete, a level 1 or a 1.5 or a 1.5, I'm going to call you in for RTI and we're going to have to do some reteaching. Some of you are at a 2 or a 2.5 and you've indicated to me that you plan on reassessing. I'm not going to pull you in 3 days a week during RTI to babysit you doing your work. If you're going to reassess, do you know what's needed to reassess? Yeah, I certainly hope so, because we talked about it last week, didn't we? You have all 3 of those emails. If you know which standard you're going to reassess on, you're focusing on that particular email that I sent that says standard number 1, standard number 2, standard number 3. And you're following that process. Now, as the email says, if you have any questions on the process, the homework, or the remediation worksheet, you should come and see me. But I am not going to be able to walk around to each and every single one of you and go, hey, remember, you said you were going to reassess on the standard. You need to make sure you're doing it. That's up to you. Okay? But again, at the end of the day, if you don't make the 10-day deadline, you're not reassessing. Just because you said you want to, that doesn't grant you extra time. 10 days is 10 days. Okay? Your deadline for reassessment, according to the worksheet that I gave you, is the 29th, and today is the 21st. That means you have until next Wednesday. We are almost halfway through the remediation process. We're in day 4 of 10 days. Now, again, the nice part is you had 2 weekends in, or you'll have 2 weekends in here, but if you walk up with me, or walk up on the 29th, and you hand me everything and then say, hey, I'm ready to reassess, that's not going to work. You should hand me your homework and the remediation worksheet. And I have told you that I need at least 24 hours to sort through that, confirm that everything's good. If everything is good, then you can reassess. If it's not, you're not reassessing yet. And so I'll use my algebra class as an example because they're already through it. Their 2-week deadline is tomorrow. If somebody hands me something today and there's anything done on their or wrong on their reassessment worksheet, they're not reassessing tomorrow and their 10 days are up. I'm not going to extend it because I waited for 7 days to start to do anything. Okay? So, this is on you at this point. It's not on me. And again, I know that this is different. My wife's a middle school teacher. She would walk down to Mr. Payton's room and grab you out of WOW and say, this is where you're sitting, until you reassess. That's not happening here. Because I'll be honest, some of you, I can't even request you for RTI. Because you're not in an incomplete, but you have an incomplete or 2 or 3 other classes, they're going to request you every day of the week. I can't look at a teacher and go, well, they're at 85%, they want to reassess in here. When you're at 0% somewhere else, they have priority over you every day in my book. Okay? So this is on you, nobody else. Okay? All right, one other quick thing. And again, I'll be honest, I don't do a great job with Power School learning and whatever, but we've had more and more people being gone. If you're gone and you are not here when I assign homework, one of 2 things. Number 1, you can always email me. Okay, but I'm going to be very, very honest. Like yesterday was an example. I was out of the building at 4 for practice, and I don't come back to my room until about 7. So I reply to emails, but it's not like in a timely fashion after school. So I think I replied to some at 7 last night, and then I sat down at work or home to do some get ahead notes, and so I replied to emails about 9:30 last night. But I'm not going to reply at 5, I'm not going to reply at 4 or 4:30 because I'm at football practice, and when football's done, then I'm at basketball practice. So pretty much I'm not here after school until like March. Okay, I'll get stuff to you, but it's going to be at random times. The other thing is, and this is what I've been trying to do to help you out more and more, I put the night's homework in Power School every day before I leave. So like last night's homework, page 186, whatever, 2 through 6, 12 through 19, I put it into Power School before I left for practice. So if you go home and you're like, I don't know what it is, log on to Power School, click on your math grade. The most recent one is going to be at the very top. That's what I'm collecting the next day. Now again, if you're not here, then I give you kudos for reaching out. I'm not upset that you didn't get it done, but I'm just telling you these are ways that you'll be able to figure it out. The reason I'll be honest, the reason I don't use Power School Learning a whole lot is because I don't have time to update it every day. In this class, we do what we're ready to do. We don't do something, I can't tell you in 3 weeks what we're doing on Tuesday. I can tell you what I'm doing this afternoon. I can tell you tomorrow we're taking an assessment, but I can't even tell you really what we're doing on Thursday for the entire day until I see how we comprehend everything. Okay? All right, any questions with remediations, the tickets, homework, anything else like that? All right, then we're going to continue with our lesson. So go ahead and grab out your 4.3 notes that we started yesterday. All right, so yesterday we defined what equivalent fractions are. And here's what I want us to understand. We're still going to be talking about equivalent fractions the rest of today. But we're not going to just say write an equivalent fraction. We're going to say reduce this fraction into lowest terms. When anytime you reduce a fraction, you are going to be writing an equivalent fraction. But there's a catch to it. You're going to multiply or divide by a number, but here's what needs to happen when we get done. This is our definition for the day today. So simplest form says this: a fraction is, in simplest form, when its numerator when we say numerator, what are we talking about? The top number. And denominator which is the bottom, are relatively prime. A fraction is in simplest form when its numerator and denominator are relatively prime. Now, I'll be honest, most years when I teach this, like if we hadn't already talked about relatively prime, I wouldn't use that phrase, but we talked a lot about relatively prime last week. What does it mean for two numbers to be relatively prime? Serena? All right, when the greatest common factor of those two numbers is 1. It doesn't mean that the numerator and denominator are prime. It means that they have no common factors other than 1. Now, yesterday, we went ahead and I wrote out in your notes, this is how you write equivalent fractions. I did the same thing down in the bottom as we start to get into writing reduced fractions or simplest form. Okay? So, to write a fraction in simplest form, right here, it says that we are going to divide the numerator and denominator by the greatest common factor. Now, if I want to reduce my fraction in one step, then I need to find the greatest common factor. If I don't care how many steps it's going to take me, then I simply need to keep finding a common factor until my numerator and denominator are relatively prime. So as I work through some of these scenarios here, I'm going to show you some different ways to do them. Okay? Because here's the thing. I don't want us trying to reduce fractions and spending 10 minutes trying to find the greatest common factor. Sometimes, ladies and gentlemen, just find a common factor and then start breaking it down. Okay? So, for problem number 2a, write the fractions in simplest form, show all work. We're still not getting away from this. You must show all work. So when I look at 4 and 14, are 4 and 14 relatively prime? No. Okay? I know, at least when I look at the beginning of these two, that they're both even. So if they're both even, then both of these numbers have to be divisible by what? 2. They have to be by 2. Now here's the thing. I don't know if 2 is the greatest common factor yet, but I definitely know that 2 is a common factor. So what I would do in this problem is I would divide the top and the bottom here, each by 2. Now, just like we did yesterday, we're just simply rewriting this as an equivalent fraction. So I'm going to divide the top by 2, I'm going to divide the bottom by 2. So if I take 4 divided by 2, we're going to be left with 2. And if I take 14 divided by 2, we're left with 7. Now, if I don't know if this is the greatest common factor, then I still need to look to these two numbers to see are they relatively prime. Are 2 and 7 relatively prime? Yep. Therefore, this fraction is reduced. Now, I want to show you B in a couple different ways. Okay? If I'm trying to do this the fastest way possible, then I am going to find the greatest common factor. Does anyone know what the greatest common factor between 12 and 30 is? They're both divisible by 6. So, if we recognize that, then what I would suggest is you divide the top and the bottom each by 6. So if we divided the top by 6, 12 divided by 6 is going to leave us with 2, and 30 divided by 6 is going to leave us with 5. Are 2 and 5 relatively prime? Yes. That fraction is reduced. Now, not everyone is going to recognize 6. So here's the other strategy. If I have 12 over 30, I know these are both even. So if I know that they're both even, they both have to be divisible by 2. So if I divided the top and the bottom both by 2, 12 divided by 2 is going to give us 6, and 30 divided by 2 is 15. Now, are 6 and 15 relatively prime? No, because they're both divisible by 3. And when they're both divisible by 3, 6 divided by 3 becomes 2, and 15 divided by 3 becomes 5. Are 2 and 5 relatively prime? Yes. Now, this ties back to what I was showing some people on Friday and what I showed you guys yesterday. Look what happens when you multiply these two numbers together. What do you get? You get 6, which happens to also be the greatest common factor. So remember when I did that earlier today and I showed you that you can just keep pulling out common factors? And once you pull out all of them, you can multiply them together and get your greatest common factor? That's exactly what you're doing when you divide fractions. Okay? I'll be honest, I don't spend a whole lot of time finding greatest common factors. Now, if it's a small enough set of numbers, I already know the greatest common factor because I do a lot of work with this. But otherwise, this is the process that I follow. I just continue to break down the top and the bottom until both numbers are relatively prime. And once they're relatively prime, then I know that my fraction is reduced. Now, when we come back during 7th period today, I'm going to show you a different way that most of you have never thought about this before. So that way when we get to the back and we have fractions, you're not going to be, fractions with variables, you're not going to be shocked on what happens there. All right, so you can pack that up. If you would, please make sure, again, covers are on your calculators.